Hello everyone, this video will show you solutions for lab 2.5.2.5 from the course Big Data and Analytics from Cisco. And as you already know, I'm already now connected to the Raspberry Pi, and this lab is going to be about Internet Meter and SQL. So in the first part, we're going to set up a database. Part 2, we will connect to the database and manipulate database with pandas. So these three parts are already covered also in the previous video. So please, if you didn't check the previous video or did not do the lab, then I recommend you to do so before you continue with this lab. Okay, in part 4, we are going to see how to join tables with pandas. Okay, so the scenario here that we have a database, a big data, and then we need to manipulate this data. However, let's move forward and let's start with set up our database. And as you already know, we need to install SQLite 3, and first we need to update the packages in Linux. And since they are starting with exclamation marks, then they are Linux command, and we can do this through Jupyter. You also can use this through a new command line interface like this, but I'm going to stick and do everything to Jupyter with Jupyter. Then we need to create a database, and the name of the database is internet speed. So we can use this command here and put exclamation mark and then put the command, and the command here like this, SQLite 3 internet speed. This is the name of the database, and then databases. Okay, so we can now go and check under Big Data Analytics Chapter 2. There should be this database. Let's do this. So here we are under Chapter 2, and this is the database. Okay, so let's keep going. And here, what we also need, we need to use the CSV kit, and this way we need to merge a database or a file with big data with our database. So let's also install this package. This package is already installed in the previous video on this Raspberry Pi, so you will see everything requirements are satisfied. Okay, what else now? We need to we are going to use CSV SQL to insert data from a table or from a database or from this CSV file into our database. Okay, so here we are specifying that this database insert the data from this CSV file, which should be available under the data. So if we go there and then here, then we have this file is there. So the content of this file or data in this file will be important to our database. Okay, so to do this, first we are going to check if this file is already existing, then we delete it. Then we use CSV SQL to generate this file and insert to this file this data. This is just to ensure that everything is fresh. Okay, so let's do this one. And this may take a while. However, then after that we are going to connect to the database. To connect to the database, we need to import SQLite 3. This is a pandas and matplotlib to draw figures. And then to be able to connect, we have to use the SQLite 3 connect method, and we specify the name of the database under this. And after that, we need to use the cursor with the connection. So the output of this will be in an object called connection, CONN, and then we use the cursor to reach the table. Okay, so now still executing. However, after that we can solve this. Let's prepare this one here. So to connect to the database, here we need the name of the database, and after that we need to create a cursor. So here it's going to be this is the cursor for the database that we will connect. Let's check up if it's finished. Yes, it's finished going, and now let's connect to the database. So first let's import the modules. and then after that let's create the connection and assign the cursor. Okay, so if we would like to generate any query, then we have to execute, like cursor execute, and then we specify the query. The query should be written in advance. Okay, so here what we need to select the first 10 rows for a data time column. Okay, so let's write the query for this. So first we need to specify the query, and here select from the date time. And here from the table that we imported, which was the name of the table, is this LA. This is the name of the table. And then order by, here we need also again we need to like date time be ordered, and then we need 10. Okay, and then we execute the query. And then we specify here the query. So there we execute the query, and then we specify, let's run this one, and here we have the object. Okay, and now if we would like to print the query we have executed, then we make a for loop, and then we print in for loop, and here we will have the query. The database, there is no way to always have them in order, so then we can use a random. So because here it's mentioned as well that this is because SQL does not have an intrinsic ordering of the rows, and we are dealing with the time series that without the correct ordering don't make any sense. So select a random sample of rows would remove the temporal component. Okay, so it shows here how to specify the query with a random. You just add random here, because here we order and then we just use random here. So if you run again, you will find you always have random rows. Okay, now we would like to focus on a portion of the data. So here we have a big data, and we are dealing with more than 900 columns. So it's possible also automatically to retrieve the name of the columns and put them in as a list. So the name of the columns will be handy, and we can manipulate and work with this. So as you already know, names of the columns are always on the first row, so we can execute them or extract them. And as you can see with this query, so from everything from this table, we need only the first row, and then we execute the query, and then the query now by default with the SQLi3, the name of the columns will be under description. Okay, so as I mentioned, automatically the name of the columns will be in the description field, which is under the cursor that we specified. So here we print the first 10 columns from them. So as you can see, this is what we need. And by the way, this is the name of the area. It's in this. So as I mentioned, you have to know about the database that you are working with or about the big data. So in the description on this file, if you will read in the previous, like in the scenario, you will know that this one is the area, and here this is P for ping, U for upload, and D for download. So from here, like if you are watching this for the first time and you will see, what is this? How can I know this is? Of course, you really need to get information about the big data file that you are working on. Okay, so the task here in Python that we need to extract only this one. We don't need this. We need the name, like the name of the columns here. So as you can already see in this code, so we are going to create a new column called columns variable, and we put in it the first value of this. Actually, here you can see there is a tuple, and from the tuple we need only to extract this one, which is as an index 0. So according to this, so member 0 will be here what we are going to take from this, we are going to take from member 0 the first element in the card description, which is this one. So this value will be here, only this one. Okay, and then we like ignore the first one. We not start from 0, we start from 1 till the end. So if we run this one, so the output is going to be from 1 till the end. As you know, this is a list, and then it's going to be connected to the um, to the file itself. Okay, why we ignore this? Because at position 0 we always have the name of the field. We don't need the name of the field anymore. We need only the data. So we need this one. Before this one, it's going to it should be like the name of the column itself. Okay, for more explanation about this still here, so we have the columns here, and we put in it the data from the first from the description, as we mentioned, and if we are going to print this one, so we will see that we will have the index. So let's run this one, and we will see now we have index, area, average P, and average U, and we don't need the index anymore. So to drop it, so we can start the columns from first area. So we will have area, average B, average U, and so on. So let's now print again. We will see now the output here that the index is dropped. Alright, so as I mentioned here, this is the columns contains now the columns contain the measurement of the speed and the geographical area, and this is the name of the area, and this is the suffix. So the suffix P for ping, U for upload, and D for download. Okay, what we actually assume that we want to do, we don't need the suffix, we need to delete them. We need only the name of the area. So to do this, we can use the replace method, and we replace if it's minus P, then put nothing, and minus D put nothing, and here for minus U, we always can also put nothing. So here actually we can just put this one here, and then we specify minus U. Okay, so if it's minus U for upload, then put nothing, and then this list the set of columns, and then we print them, and here we remove them. Okay, so as you already can notice here that we remove them. After that, the best way to understand, like it's mentioned, what is there, so we print the first one from this, and we put it in an area, and then we print the area, and we have this value here. Okay, as you can see now, we want to visualize the data like relative to the area, this one, but we have this one here now, and so to do this, we can make a query first, and we will like bring everything from the data set, and then we print in. Of course, we need also to specify the suffix. So if it's minus P, we are going to make a dictionary, or there is a dictionary here for minus P for ping, minus D for download, and minus U for upload. This is the key, and this is the value. And as you already know that if you print the key, then or the keys, then you will reach the value. Okay, so this is the keys, and these are the keys, and these are the values. So as a dictionary, if you would like to reach a value, then you can reach it through the key. Okay, so the idea is like this. First you make a query, then you use a method called fetch all. So you will fetch everything from the query, and then you specify with the plot the suffix, which is the suffix s here, which is the specifying the key, but you will print the value. Okay, the code is here. Now we have the area 0, which is for the first one, for the first area only, and we have a figure. The size of the figure is going to be 10 and 8. This is the size, and then here we print for s and suffix. So for each one in the key, for the ping, for the upload, and for download, we are going to go and make a query. Okay, so let's do this also. And here what we need to create a query. So the query is going to be like select, and here we put everything like in curly brackets, and then and after that we specify from the table Wi-Fi speed, and then we need order by date time. Okay, and then we specify the format and area S. Okay, so what is happening here, that you can write it in this format. Select area S, you don't need to specify this, but just to make it more decorative, the code, we put the format in this way. So when you format and there's curly brackets, then you put them here directly, and in this way you don't need to specify, you know, the print with format. We already talked about this in part 1 from this course. However, you, as I mentioned, you can put area and S here, there is no problem. And here from this table, bring them, and this is the query. So the query is going to be like the area and the S. What is the S here? Is the ping or download or upload, because S is a key actually in this dictionary. Then we execute the query. And then after executing the query, we use the method called fetch all and bring everything, and in the label we put suffix of ls, which is going to be ping, download and upload. And then we put the legend and then put the title. The title is going to be the area, which is this one here. Okay, so here we have a problem, says that no such LA Wi-Fi speed. Here we have a problem with this table, the name of this table, so let's bring it from what was the name of the table exactly. So the name of the table okay, this is the name of the table, and we miss UK. So let's copy paste it from here and put it here. And then run it again, and here we have the figure for only this area, not all for the data. This is only for this area, and it's over from 0 to 1000 and here to 80. Alright, now we need to manipulate the data with pandas. Okay, the goal now is to calculate the average Wi-Fi speed for all the areas in the dataset. So now we don't work with one area, we're going to work with all the areas. Pandas can help in sorting and visualizing the data easily. Okay, so what we need to convert all the like measurement to average. So what is going to do? We are going to create an empty data frame with the specific columns. So we have area. For each area, we will have average ping, average upload, and average download. Okay, so to reach this, we are going to have this one here. This is the name of the new data frame, which is an empty one. And here what we need to specify that the columns is going to be this one. Okay, so one more time, what we are going to do, we are going to create a new data frame, and the new data frame is with these columns, and then we change this list to a data frame. Okay, let's run this one. Okay, what else we are going to do? Actually, we are going to loop over the list containing the name of these areas, and then loop over the tree suffix, which is for ping, upload, and download, and then write a query to select the area and the metric of the area, and then we execute the query and fetch the result. Now with fetch 1, and then append the average to the temporary list. At the end of this loop, we are going to insert the temporary list into a data frame, which is called the append, and with the method called append and the parameter which is going to be ignore index. We don't need the index anymore. Okay, so to compute the average, what we are going to do now, we have an empty list. first we go through all the columns, and here as you can see the name of the columns like 4, 1, 2, 3, 4. Then we are going to have till 3 because from 0 till 3, this is the name of like the starting from each of them, and then the empty list, and then append the list with I. And here we make a query. So for the query, what we need actually here, we need to retrieve, as I mentioned, the area. I mean the area and the S, which is we have made already for like the thing, upload and download. This is the query. Again, select average, and this is the method for like taking the average. And here we can write columns I and S, or you can use the format. I recommend you also to use the format, and this is the name of the table. And then we execute the query, and then we use the fetch one, which calculates the average, and then we append the average for the first one, because it's going to return for the average here is a list, and the first one is the average in the mean. Then we put it in the list, and finally we put the append for the list, the temporary list, and columns, new columns, and the ignore indexes true. And then we need to visualize if we want. So here is going to be the data frame, and then we specify here head. This is going to be like this. After that, it's also possible to visualize the average of each area using the plot. So here we have a plot figure, and then we have a plot, we have index, and then we draw 3 of them, and then in a circular format. So here we have the output for them. We can specify here 2, and then run it again. However, here we have the area, here we have average for this area, here we have average for the upload, here we have average for the download. Okay, then we need the index now 0, 1, 2, 3, and then we are going to draw these figures. Let's see the output here, and as you can see here now, all for small circles, and then this is the output of this like for the areas. Okay, what we need also again to save our work, so to save the new data frame to a table in the DataSpeed database, then we need to actually do the code here. So here we make sure if the average speed is there, then we need to drop it. Otherwise, we don't need to do anything. And then we need to save XDF to SQL, and then we specify here the average speed. This is the name of the table, and then we specify here the connection. Okay, let's run this one. Here we have average speed is not defined yet. That is correct because we need to put this one here. And after that, we just need to check everything went okay. So here we make a query, and then execute the query 2, and then fetch 1 to fetch the first of the record, and then print. So here we can see that we have the area here, and here we have the average for 0 and 1. Okay, in part 4 we need to join the tables, and this table, like the information can be found here in this table here. So we create a population. So first of all we need to close the connection, and after that we need to put the new table into the database. So, and to do this we can use this line. So here, as you already know, this is CSV SQL, and this is the database. To this database, insert this table, which is LI population. And after that, we need to make a connection again. So here we have to connect one more time. So which database? Actually to the internet speed database. Okay, and then we create a connection. After that, we need to make a query, and the query here that just to check everything worked fine. So here query select everything from the table, blah population and put 10, and then we execute the query, and you already know what is happening. Now we execute the query, and then here we need to only print the row. Here what we have now, we have the new information, and at the end we only need to execute the join query and to print the first 10. So here we have the query that we already written here, and the query select everything from the average speed and join this on this table here, and here we have the query there, and then we execute the query, and now we have k equals 0 for k and less than 10. Then if it's bigger than 10, then break, otherwise print row. Okay, so just to print, here we have row, and of course we increase k by 1 because it is going to happen that if for row in because k here is a counter starting from 0. This is the way to calculate this. There is the output here. Okay, so that's all for this lab. Please try to do this lab by yourself, and I'm sure you will have questions. Please, I'm happy to have your questions, and we will talk about these questions in the lab. Thank you so much, and see you in the next video.